Good day! In this video, we are going to do an excellent question on a coordinate geometry internal. So we are going to do the application of coordinate geometry. So in coordinate geometry, you need to know how to find the gradient, the length, the midpoint, and from that you can apply to solve any coordinate geometry question. So this is a typical coordinate geometry question, and they ask you to show that A, B, C, D with the coordinate -1, 1 for A, 8, 3 for B, 9, 7 for C, and D, 0, 5 is a parallelogram. So before we even start, we need to roughly sketch the graph. You don't have to be accurate. So A is -1, 1, B is 8, 3, C is 9, 7, and D is 0, 5. And we need to show that they are a parallelogram. If you do not know what parallelogram, the opposite sides of the parallelogram, they are parallel to each other. That's why it's called a parallelogram. They have two sets of parallel lines. So the other set will be these two. Okay. So AD is parallel to BC, and at the same time AB is parallel to DC. So to solve that it is a parallelogram, we need to show that the gradient of AD is the same as the gradient of BC. At the same time, we need to show that the gradient of AB is also the same as the gradient of DC. So without further ado, let's try to solve this. So to find the gradient of AB, we're going to calculate this gradient now, okay? Mine is not accurate, the graph, I just do roughly. The formula is y2 minus y1 over x2 minus x1. So you can take either one as x1 and y1. So in this case, we take the bigger number to minus the small number. So y2 is 3 minus 1. So they'll give us 2. 3 minus 1 divided by 8 minus 1. So it's going to 8 plus 1. So the answer is going to be 2 over 9. That's the gradient of AB. So we're going to put here gradient of AB is 2 over 9. Okay. So similarly, we're going to find the gradient of CD or DC. So gradient of DC or CD, it doesn't matter. Okay. It's also going to be y2 minus y1 divided by x2 minus x1. So we take the bigger number. So 7 minus 5 is going to be 7 minus 5 divided by 9 minus 0. So it's going to be 2, 7 minus 5 is 2, and then 9 minus 0 is 9. So we can see that the gradient of AB is the same as gradient of BC. So the gradient is also going to be 2 over 9. And now we need to calculate the gradient of AD and BC. So again, we're going to calculate gradient of AD is going to be y2 minus y1. So we take the bigger number. 5 minus 1 is going to be 5 minus 1. And the other one is 0 minus 1 is going to be 0 plus 1. So it's going to be 5 minus 1 is 4. 0 plus 1 is 1. So the gradient is 4. Okay. Similarly, gradient. So we're going to put gradient is 4. And we need to calculate the gradient of BC. Is again y2 minus y1. So we take the bigger number. 7 minus 3 divided by 9 minus 1. 9 minus 8, sorry. So it's going to be 7 minus 3 is 4 over 1. And again, it's going to be 4. The gradient is 4. So to prove that there is a parallelogram, we can claim that the gradient of AB is the same as gradient of DC. So that's one proof. And the second proof is that the gradient of AD is also the same as gradient of BC, because they are both 4, and we have proved that it is therefore A, B, C, D is a parallelogram. So that is a common question, and hopefully it will appear in your internal. Cheers everyone, and have a great day.